Today's topic is multiple regression. It'll take us a few class periods to get through that. Multiple regression is essentially where we have more than one X variable, but in a sense it's good. All the stuff that we do here is good for simple regression too. So we'll just say that this is a generic situation where we have one or more X variables in the regression. So instead of having sales being predicted by, say, just advertising, sales could be predicted by advertising, price, the region of the country, time of year, and many other things that you can imagine. The form of the population equation now needs to be able to reflect the other X variables. Remember, the population equation is in a sense, the hypothesized relationship between the y's and the x's. Y is equal to beta 0 plus beta 1 x1 now. We'll put subscripts on the x's plus beta 2 x2 if we go that far. But in general, we'll write this equation through beta sub k x k, where k clearly is the number of X variables in the regression. Note that when the data goes into the computer, you'll have a column of Y data. You'll have columns for X1, X2, and however many you need. But unknown to us, in a sense, what the computer program does is, unless you tell it otherwise, it'll insert a column called X0. And that X0 takes on the value 1 for each observation. So in a sense, X0 is not really a variable like the other X's are. X0 is 1 for each observation, and so X0 is called the constant. You'll see that name and terminology pop up on computer outputs, and it's important for us later to understand that that column of ones is out there. Alright, what about the form of the sample equation, or the estimated regression? Estimated or sample regression. Alright, very much like you'd expect, it's y hat is equal to beta hat 0 plus beta hat 1 x1 plus beta hat 2 x2 plus dot 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 all the way through to however many you have, beta sub k xk. Alright, the beta hats these days are all provided to us by a computer program, as well as some other information. For each of the coefficients of x, that does not include beta hat 0, we need the associated standard error, like what we did in simple regression. So instead of s, we had s of beta hat 1, we'll now also have s sub beta hat 2, all the way up through s sub beta hat k. Again, computer will give us all that. Computers will give us other material also. For instance, we will talk about a concept called R squared, which measures the strength of the regression. way similar to the little r in simple regression, and little r and r squared are related to each other. And we'll also need to do a test for the significance of the entire equation or the entire regression. That is, not just each individual x. In simple regression, we could test to see if the one x was significant, and if that one x was significant, then the whole equation was, since that made the equation. Now that's not so. One or more x's could be significant or insignificant, and that doesn't tell us anything conclusively about the significance of the entire regression. And when we're done with those, we'll then do the t-tests, plural, for the significance of each x individually. Alright, first time we do this right here, we'll do this in reverse order. Do the t-tests, then the test for the significance of the entire regression, then talk about r squared. But in the long run, we'll do it in the order that they're listed. We'll look at the r squared and do an interpretation, since the interpretation is meaningful. Look at the test for the significance of the entire regression, and then the t-test for the significance of each of the individual x's. Alright, what we need to do is to do this with an example, and the example we'll do this on is on the website called the truck example. In that example, the y variable is the number of what are termed Class 8 trucks sold in the U.S. Class 8 trucks actually being just the trailers, the tractors on semi-trailers, not the trailers, just the tractors. Alright, and they'll be in the order of 1 or 200,000 trucks sold annually in the U.S. We will use two variables in an attempt to predict the number of Class 8 truck sold. The first one will be the average price of all trucks. We really would like to have the average price of the Class 8 trucks, but that's not available, so we're going to use all trucks as a similar measure, and hopefully they're closely correlated. And the other x variable, we can call that the usage variable. It's the number of ton miles of cargo moved by the existing stock of trucks. So before we go into it, if the price of trucks increase, then we fully expect that the number sold will go down. Right? Basic supply and demand function. Alright, so then going to x2. If x2 increases, that is, if the current usage or number of ton miles of cargo moved in the US by the current stock of trucks increases, trucks in that stock will wear out and break down and need to be replaced by new trucks. So if the usage goes up, the existing stock of trucks, then we fully expect that the number of Class 8 trucks sold, new ones, will increase. Now, the regression equation may not give these results, but that's what we expect.